Question 14. Temperature can be measured in degrees Celsius or degree Fahrenheit or Kelvin. The functions for converting Kelvin to Celsius is given by F functions. So we know this function is going to help us to convert Kelvin to Celsius. And the functions for converting Celsius to Fahrenheit is given by these functions, Gx. So G is going to help us to convert whatever Celsius to Fahrenheit. At certain time, the temperature at the peak of the Mount Kinabalu is 41 Fahrenheit. Find the corresponding temperature in Celsius. So it means that now we have 41 degree Fahrenheit. And we want to know that what is the degree in Celsius. Do we have any functions to convert Fahrenheit to Celsius? Let's see. But no, you see, this is C to F, but not F to C. But we know that the opposite is true, right? Means that if we terbalik it, means if we reverse these G functions, if we reverse it, we will get F converted to C. So how do we reverse the G functions? We find the inverse function of G. So let us try to find the inverse G. How do we inverse again? Is learn it yourself. First step, let y is equivalent to the functions here. Second step, interchange the x and y. The last step is going to be solve for y. So when we have a plus 32 here, go to left hand side, become minus 32. When we have a times, go there, become divide. So fractions have no divide. So what should we do? We just interchange the position of 5 and 9. And this is our inverse functions. We're done. So our function will be 5 over 9 times x minus 32. So now they ask us to find, hey, want to know that what is 41 Fahrenheit in Celsius. So we just need to key in by using our new functions here when our temperature is 41 Fahrenheit. So 4 over 9 times 41 minus 32. So we know that we just need to compute this one into our calculator. We can find out that the answer is eventually 5 degrees Celsius. How about the next questions? Find the functions for converting Kelvin to Fahrenheit. So do we have these functions? Kelvin to Fahrenheit? It's no, right? It's impossible for us to find Kelvin to Fahrenheit. But what we know is we have Kelvin to Celsius. So we have Kelvin to Celsius, but we also have Celsius to Fahrenheit. So eventually we can do two steps here, right? It means that what we're going to do is we're going to do first from Kelvin go to Celsius, Celsius go to Fahrenheit. But what is the functions when we want to find Kelvin to Celsius? We know it's the F functions. It's the F functions here. How about from the Celsius to become Fahrenheit? We know it's the G function here. It's G. So these are the two-step functions, but they only ask us to find one functions. So this is where we need to use our composite functions, where we combine two functions to become one. So which one go first? We know. We need to compute F first. Whatever that we get our Celsius, then we put it into our G functions. So how do we write down is, we're going to find the F function first. After we find our F functions, we put it into our G to process. So this is how we get GFX. Or just remember that it's reverse. We start from the back, one by one. GFX. So how do we find GFX? Easy, right? Go to the G functions. What is our G function again? is 9 over 5x plus 32. So 9 over 5x plus 32. But what is our input now? Our input is fx. Fx. What is our fx? Our fx is x minus 273. So 9 over 5 is x minus 273 plus 32. So once we have this one, we just need to compute. So it's 9 over 5x minus 9 over 5 times negative 273 plus 32. Question 15. Given the function gx is equals to 5x plus 3, find when the input of g is negative 1. So this is very easy and straightforward. We just need to put in negative 1 as our input into our processing here. So what do we have here? Negative 5 plus 3, which is negative 2, and we are done for A. Question number B. B tells us to find the inverse of g when the input is 2. So how do we do this is, we're going to find the inverse function first. So how do you find the inverse functions? Using learn it yourself. First step, let y is equivalent to the function given. Step number 2, interchange our x become y, y become x. So y become x, x become y. And our last step is going to be solve for y. So how to find y here? We know it's easy. How? Plus 3 go to left hand side, become minus 3. When you are together, it's a times, go there, become divide. Divided by 5. And we are done. So this is eventually our g inverse functions. So this is our g inverse function. But the problem here is, they want us to find what happened when the g inverse function receive an input of 2. So how do we do is, plug in our 2 into our x. Since it's no longer an unknown, we know you chosen 2. If you plug into the calculator, you will have negative 1 over 5, and that is the final answer. Question 16. The diagram shows the mapping for the function of f and g in the arrow diagram. So this is the arrow diagram of two functions of f and g. Given fx is equal to px minus 3, and g of x, which is the composite function, have the function of 2x plus q, where p and q are constant, means that they will never change. Find the value of p and of q. Usually for this kind of questions, we try to translate this one to become equation first. How do we translate it like this? We know this is the f functions, so write down f functions. When you receive when you receive 3 as the input, we have the answer of 12. Just imagine, when f function is this one, going this way, 3 will become 12 after they're going through the f functions. And the second way we see here g. Can you guess how do we write it? Yes, it's just g. When they receive 12, the answer is going to be 8. So these are the two functions that we can have from the graph. Is there anything else? Yes. Don't forget that we also learned about the composite functions, where we can do a shortcut. How to write the shortcut is we reverse it. Start from g, f, x. This is how you write down the functions of composite functions. Because why? We need to settle fx first, which is at the front part here, put into the g. So this is like whatever the fx after we settle, we put into our g. So this is how we say that from 3 go to add is eventually gfx. So can we write that now? Yes. gf, when they receive 3, we will get add. So these 3 are going to be our information that we get from the graph. So we put it here first and see what can we do next. So now they say that, hey, the function fx is same as px minus 3. So we just substitute this one and compare with whatever that they given to us. So now x is no longer unknown because why? We know it's 3. So let us try to do now. f3 is equals to p times 3 minus 3, which is equivalent to 3p minus 3. But we know the answer is going to be 12. So 3p minus 3 is 12. When you have a minus, go over there, it becomes plus. 12 plus 3. Together is a plus, together is a times, go there, become divide. So p is equal to 15 divided by 3, which is 5. So once we found our p is 5, we now need to proceed to the next function, which is gfx. The given gfx is equal to 2x plus q. But we know that the gf when input 3 is equals to add. So let us try to input 3 into gf functions. So gf, so let me try to use other color now. So gf when it's 3 is 2 times 3 plus q, which is 6 plus q. So we know gf when input 3 is 6 plus q, which is also equivalent to add. When you have a plus, go over there, become minus. So q is equal to add minus 6. Q is equivalent to 2. And this q equal to 2 will be our final answer. Hey, if you have any questions or would like to see any kind of video, do leave your comments below and let me know. If you want to support us so that we could make more videos like this, the simplest way is just by sharing the video with your friends. Click the like buttons and consider subscribe to this channel. See you in the next video.